Hello everyone, this is the video lecture for Algebra 1314, Section 4.3, Properties of Logs. I'm trying to speak into your ears now, a little bit of ASMR math. Ooh, it's just so cool. Let's just type some cool numbers here, right? Yes. Yeah, that's not numbers, Chad. Sorry. Anyways, I was just joking around and having fun with you guys. So, we're doing properties of logs. It'd be great. I think this is like from chapter 1. So I'm just going to remind you what's going on here. If you multiply your bases, you're going to add your powers. When you're dividing your bases, you are subtracting your powers. And when you got powers of powers, they actually multiply. So there you go. Sweet. Had nothing to do with what we're going to do. So properties of logs, they are similar actually. If you're multiplying on the inside, what happens is that you split them up with a plus sign on the outside. If you're dividing on the inside, you guessed it, you minus sign on the outside. And then finally, if you have a power p, you can bring it down to the front as a multiplier that looks like that, okay? So these are equivalent. They're literally equals, like an equal sign between each of these guys. What we're going to do in this section is we're going to rewrite our logs in one way or another. I have to say that this is one of my favorite sections, and I think maybe because Desmos is not very useful. Okay, a lot of the times in the previous sections we can use Desmos to basically just get our answers. Not so here, not so. None of this is Desmos worthy. So we have to do it as humans, and that is cool. So let's do some fun math here together. So we got log base b of this thing, and it says rewrite it. Basically, I'm using these properties up here and seeing which ones make sense. I have to say that these problems are a little bit beefy at first. They're pretty big. I would almost rather do like simple problems first. So if you don't mind for just a second, cutting into that a little bit, let's do a couple easier examples before we go into the hot mess that is, okay? So let's do log of 2x. This is just pretty simple. Notice that it's 2 times x. So I got log of 2, and then that time sign turns into a plus, and then I got log x. And there you go. You're done. That was it. There's a multiply symbol right here implied. That multiply turns into a plus. There it is. So let's do another one. Let's say I have log of 3 divided by y. And so I can split this up to say there's a 3 and now a minus sign and then a log y. So the same things, it's just that this dash mark turns into this dash mark, right? Isn't a time sign like a multiply? Like if I did 2 times 3, couldn't you have used a little cross symbol instead? Ooh. And if you take that cross symbol and you go, and you rotated it just a little bit, wouldn't you get a plus sign out of that? Ooh. Dash mark, dash mark. I'm just doing like memory tools. Okay, so multiply goes to add, division goes to minus. The last one is a power thing. So let's just say I have like log of, I don't know, x to the 4 or something like that. I could take that 4, move it to the front. So it's 4 times log of x, and you're done. So there you go. Those are just like some quick examples of what we're doing. And now we're going to apply them to the bigger problems now. So what is in between these two guys is an implied time sign. And so the times means that we're going to have a plus between them. Okay. Now, we're not done because just like this 4 can come down to the front, the 3 can come down to the front. Also, this square root is a power. Do you remember what power that is? I said it in the last section. What's the number power for a square root? Oops, not an equal sign. It's half. It's half. Did you get that? So it's a half power, and there you go. We're done. So if you see a square root that's technically a half and bring it to the front, you're done. It's like saying c to the 1/2. I mean, and I just brought it to the front. So that's a square root. This is a cube root. So not 1/2, but 1/3. It's like, so whenever you have a square root, technically there's a little 2 in there. You just don't see it. That's an invisible 2. So 2 means half, basically. All right, so let's do this one. Notice the big thing that you see, right, is minus sign, right? Well, division. Division, which means a minus. I got ahead of myself a tiny bit. I tend to do that. So yeah, big division means a minus sign. There you go. I'm now going to move this down to the front. That's a multiply there, Chad. Yeah. Yeah, it is. It is a multiply. You did well in seeing that. Therefore, oops. Well, I just gave it away. No! Okay, just ignore that I did that for a whole second because I wanted to show you. Multiply means plus sign, right? Right? And I'm going to say, yeah, all this is wrong. All this is wrong. It's wrong. Because you need parentheses, which I was putting. I'm saying that like all of this has the minus sign, so the minus sign applies to both of them, and that's what I need to be able to do. So they both have a minus. Some other things that I'm going to clean up. So notice that I have 5 and 25. I think that will cancel or something, right? Oh, it's a 2. So yeah, of course, it's 5 to what power is 25. 5 squared is 25. So this whole thing turns into a 2, so that's kind of nice. And then again, I'm distributing a minus sign, so that's now going to be a negative. The 8 comes down to the front, and there you go. I got to say, this is kind of getting complicated. Whoop, whoop. There you go. Let me do this one, and then I'm going to then show you a quicker method that I think will be easier for you. So, but I still want to do this one the long way because I want you to be so in pain, so hurting when you see my method that you have to turn to me, that I'm the only hope you have. I don't know if that's a good or a bad thing. Anyways, this whole thing is a 9th root, and so you can pull that out right now as a 1/9 multiplier. And then you still have all the stuff. Ooh, I did a B. Look at that. Ooh, it's a B. You can see why I don't do B's very much. Anyways. So I have a multiply here, and then I have a division there, and it's just going to get kind of weedy. So here we go. Let's do the division first. So I got log base 2 of a to the 6b minus log base 2 of 4. Now, log base 2 of 4, I'm saying 2 to what power is a 4? 2 to some power is equal to 4, and it's 2 squared. Ugh. 2 squared is equal to 4. So this whole thing turns into a 2. I'm going to run out of room here. Also, this is a multiply, so I'm going to split it up with a plus sign between them. Now, I don't have to use any specific parentheses for this because there was nothing being multiplied in the front of it, technically. I mean, just the 1/9 is for everybody. The 6 can come down to the front, and I'm actually going to leave it just this way. It's a little nasty, but, well, I don't know. There you go. I'm going to do it. Ignore that 90-something. There you go. If my math lab wants you to, like, distribute the 1/9, go ahead, but I don't think that's a thing. Wow, Chad, there's got to be a better way, right? There's got to be a better way because it's just getting worse and worse and worse than it is. Because if you just scroll down, it's like, oh my gosh, I have to do that one too. Yes, this is that moment. This is that moment where you are going to see a method that I came up with, and it's very simple. Okay, here's the rules for the Chad method. I'm going to call it Chad method. I'm going to take credit for it, okay? So the Chad method's very simple. Anything that you have in the numerator, you'll put a plus sign in the front of the log, okay? Anything that you see in the denominator, you'll put a minus sign in the front. And then just move the powers down. Powers come down, and that's it. There you go. So that's the Chad method. So numerator stuff gets a plus sign, denominator stuff gets a minus sign. I can guarantee you that I will do this whole problem right here in 2 steps. 2 steps. 2 steps for this whole problem. Like how many steps this one was? How many steps for this guy? And how many times can you mess it up by, oh, you didn't distribute the minus sign, the sign's all wrong. Yeah, I have none of that. None of that's going to apply here. It's going to be correct. And in 2 steps. So that's so nice. Thank you, Chad. Well, I haven't done it for you yet. So, I want to use two different colors. I'm going to use numerator is this indigo, and then I'll use like red or something for the denominator. So here we go. Step 1, log of stuff. So I'm going to go one by one for each term. Notice that we have a 100. That came from the numerator. Therefore, I'm going to write plus sign log of 100. Why has he got a plus sign in the front, Chad? Because he came from the numerator. Okay. X to the 4. So again, this came from the numerator. So I'm going to put a plus sign in the front. Log x to the 4th. Hey, why is there a plus sign in front? Because he came from the numerator. And then I got this cube root thing. It's all kind of together. Again, numerator. So then I'm going to say plus sign in the front. Log of this stuff, whatever it is. We'll concern ourselves later with what it is. Again, why is it got a plus sign in the front? Because I got it from the numerator. So let me change my color. I don't know what you would call that. What's this color now? It's not pink. It's not red. Rose? Anyways, denominator. Right here, this guy, denominator. So I put a minus sign in the front. Log of 3. Hey, Chad, why is there a minus sign in the front? Because it came from the denominator. And finally, we got this big squaredy thing, denominator. So minus sign, log of all this stuff. Oh my gosh, I'm going to run out of room. Oh my gosh. Where did he come from? He came from the denominator. That's why there's a minus sign. There you go. Step 1. That's one step. I only have 2 steps total, so I got 1 left. That's it. I have to finish this whole problem in this last step. I'm not going to skip steps either, by the way. So I'm going to look at each one of these individually and see if I can simplify it. So like this guy, log 100. Wait. Ah ha ha ha! Because I'm saying that's 10 squared is 100. Okay, I'm just saying what's the power there? It's a 2. This guy, the 4 can come down into the front. See, it's that whole powers thingy. This is a 1/3. It can come down to the front. Okay, this has nothing. This has nothing, and like I'll prove it. Just leave it alone. Just leave it alone. There's nothing to be done there. And then this 2 can come down to the front. I squeezed it in. All right, technically that's the answer, right? Because I said 2 steps. So I'm going to box it in. And that's it. Yay! No, I'm just playing. I'm playing. It is right. It is right. It is. Well, I mean, but hold on. Look, right here. I got a minus sign. Doesn't that mean like division or something? Hold up. So I got a minus sign on the inside of the log. No, it's on the outside of the log. That doesn't apply. Same thing here. Oh, I got a plus sign on the inside. Plus sign means multiply, right? No. That's a multiply on the inside, not a plus sign. It's a plus sign on the outside. So we are done. You're done. 2 steps, like I promised. And yes, it does work on all these other problems as well. I would say that this one's a little bit on the tricky side at first, but it definitely makes this problem a lot better. I mean, you would not mess up this problem up at all. Okay, so there's your Chad method. We're going to do the same method going backwards now. So essentially, when it says condense, they mean to go backwards. And so I'm going to do like this. So powers first, then numerator, denominator. So here we go. 1/2 can go up top. 4 can go up top. So I got log of x to the 1/2. And I got a log of x minus 1 to the 4 power. Okay. And there's a plus sign between them. So that means that I'm multiplying these things together. Or again, you could say like, oh, that's a positive right there. It's an implied positive. So numerator, put them together in the numerator. Whatever you want to do. 1/2 power is square root technically, so keep that in mind. And then we got x minus 1 to the 4th power. There you go. Bam. Let's do some more. So powers come up. There's no other power there. So ln x plus 7 cubed, and then minus ln x. The minus sign means that we're going to have division. Or you can say plus sign numerator, minus sign denominator. On these simpler ones, you could just do that. Okay. Not the last one. Okay, second to last one. There we go. The 4 can come up, the 2 can come up, the 1/2 can come up. So I have log base b of x to the 4 minus sign log base b of 6 squared minus sign log base b of y to the 1/2. So this is plus, so that's numerator, minus denominator, minus denominator. I can actually just mush them all together into a single log here. Numerator, what's 6 squared? Is it so sad? And then finally, 1/2 power means a square root. Numerator, denominator, denominator. Numerator, denominator, denominator. There you go. We did it. Okay, last one. This 1/9 I want to deal with later, so like leave him out for a minute. It's kind of like the 1/9 that was right here. Okay, see the 1/9 on the outside? I'll deal with him later, okay? So the 7 comes in. Everything else does not have a power, so I just kind of leave it alone, I guess. There you go. So this is a plus on the front, so this is numerator minus denominator minus denominator, and so I'm just going to still leave the 1/9 for a minute. Numerator, denominator, denominator. Okay, the 1/9 finally does come in, and it's a power, so the whole thing's like to the 1/9 power. But that's kind of dorky, and what it actually is the 9th root. So here we go. Okay, maybe this is dorky too. I don't really know. Kind of gross looking. Ugh. All right, there you go. Close enough, close enough. Whew, are we done? Are we done? No, we got more. This is easy though, okay? So I would ask for questions, but well, you know, it's a video recording. So change a base formula. I'm going to rewrite this because I want to. So this is log base b of m is equal to log base, I'm sorry, just log of m divided by log of b. Notice that I've changed my base to base 10, the common base. So I can now put this into Decimal Scientific. So for an example, let's say I have log base 2 of 8, okay, and it doesn't work in Scientific. So what I can now do is log 8 divided by log 2, and it comes up with an answer. So that's neat. That's neat. Silly thing is that Desmos graphing does it for you, as you already know. See? So it does that automatically. So how you want to approach these problems is up to you. If you want to do this, I would say the long way, then go ahead. There you go. There you go. 0.369. Woo woo. And then finally, this guy here, that's a pi. That's a log base pi. Put a pi right there. So here we go again. 7.8 log of pi. Bada 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 bada, and we're done. Could you still do these in Desmos graphing? Yes. Even the log base pi, yeah. I think for a while it was like messing up or glitching, so they fixed that apparently. That's a good thing. Okay. It says go ahead and graph this. That's what our specialty is actually. Log base 5 at x minus 1. It's colliding at 2, so my x-intercept is at 2. And I'm going to pick this guy. Yay, and we're done with that one. That was so easy. Whatever. And then finally this one. Now, this is an odd question. And I want to do an extra one. I'm going to leave room for another problem here in just a second. Here we go. So I need to rewrite this and then rewrite it again using letters. So notice that it's division. So that means that I have a minus sign between them, right? But if I'm looking back and forth, log 2... Aha, log 2, I found it. That's an R. So this whole thing is replaced with an R. The whole thing is replaced with an R. Minus sign. Then I got log 5. Oh, log 5 is right there. Replaced with a P. The whole thing is replaced with a P. So what do you type in here is R minus P. Okay, I'm sorry. Anyways... I didn't notice that until today. So anyways, R minus P, you're done. That was it. Yay! That's kind of weird, Chad. I know. So if you don't mind, I want to do my own, and I want to show you something else. So here's another example. Let's say I got log of 2 is equal to A. And let's do log of 3 is equal to B. And I'm going to do log of, let's do log of 8. Will that work? Yeah, it will. It will. So this is kind of different. I want to split this thing up or something. What I'm going to do is say that's 2 cubed. Okay. Okay, cool. And then, I can move that 3 down to the front. So now I got 3 log of 2. Okay, cool, cool. Oh, log of 2, I've seen that before. It's right here. Look at that. Yay! So it's 3 times A, and you're done. You're done. Don't do any else. You're thinking, oh, but hold on, Chad. There's a 3, and that's a B. No, 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 it's not. It's log of 3 is equal to B. So leave it alone. If you see log of 3 or log of 2, replace it. The whole thing gets replaced. The whole thing gets replaced. I don't have that. Do I have this? No, I don't. I don't have it. It's not the same thing. So leave it alone. You will see this on your homework, and it will be confusing. You'll sit there and be like, why did that happen? Now I showed you, okay? Now I showed you. Okay, and we're done with that section. Whew, thank you very much. Have a great day.